It's experiment time!
Good day, viewers. I'm here to discuss about the voice or sound-activated switch. This project gives a modern application for turning on devices that you have instead of switching by means of your hand. Now, this is a highly advanced technology requiring just a little amount of sound to switch on your devices. This project is operated by sound, wherein if the microphone detects a sound, it will produce an output of 12 volts to energize the 12 volts single pole double throw relay. From 220 volts AC source, voice or sound activated switch is connected to the secondary winding, 12012 volts, center tap transformer. The output is connected on primary winding and to the normally open contact of the relay. The load is connected to the output. To operate this device, when the microphone detects a sound wave, the sound-activated circuit produces an output of 12 volts to energize the normally open contact. When the contact is closed, it produces an energy to operate the load. And that gives us a complete circuit.
Before we start doing tutorial, we should be first familiarized with some pieces needed in this project. This is a microphone condenser. It exhibits a higher sensitivity than dynamic microphones. Either way, the sensitivity should always be chosen relative to requirements of the job. In other words, if the microphone has to handle very high sound pressure levels, it would be advantageous to select a unit with low sensitivity, whether it is a condenser or dynamic microphone. And this is a trimmer or potentiometers or trim pots. It is a miniature adjustable electrical component. It is meant to be set correctly when installed in some device and never seen or adjusted by the device's user. They are common in precision circuitry like AV components and may need to be adjusted when the equipment is serviced.
So this is the tutorial on how to do this circuit. First, capacitor 7, 1000 microfarad 25 volts electrolytic capacitor connected in positive terminal and to negative terminal. So we done on this part, and next is R1, that is 10 kilo ohms 1/4 watt resistors in series with our microphone condenser and connected in to negative terminal.
So next is R3. R3 is 10k ohms 1/4 watts resistor that we need to connect in positive terminal and then connected in series to the collector of TR1. TR1 is C1815 transistor. So after that, the emitter of TR1 need to connect in to the negative terminal. So after we do this, next procedure is paralleling C1. C1 is 0.1 microfarad 50 volts Mylar capacitor that connected parallel into microphone condenser. So after that, the next is R2 that also connected parallel into the C1. R2 is 1 mega ohms 1/4 watts resistor that connected series into the C2. C2 is 0.1 microfarad 50 volts Mylar capacitor that connect in series to the BR1. BR1 is 10k ohms trim pot which is connected into the negative terminal. So we're finished on this part, so we need to erase this. So next is R4. R4 is 56k ohms 1/4 watts resistor that connected in positive terminal, then connected in series into R2, TR2. TR2 is C1815 transistor that connected into negative terminal. But the base of TR2 is connected into BR1. That's BR1 is 10k ohms trim pot. And then C5 is 2.2 microfarad 16 volts electric capacitor that connected in parallel into TR2 into the collector of TR2, then into the negative terminal.
we're done with this part, we now eliminate this R4. Now we will proceed to the next part. R6 3K ohms 1 port 1 resistor is connected on the positive terminal, connected on the collector of the transistor TR3 C1815 transistor, and the collector of this and the emitter is connected on the negative terminal. The base of the transistor is connected on the diode 1. Diode 1 is IN4148 diode, connected on the R5 47 kilo ohms 1 port watt resistor, series with R7 10k ohms 1 port watt resistor, and also connected to the C4 2.2 microfarad 16 volts electrolytic capacitor.
So we've done in this part, so we need to cancel in this. There's this. So next, we proceed to this part. So first, we connected D3, the I3, which is 1N4148 diode that connected into positive terminal, and then connected in series into the TR4, that also C1815 transistor, and then the emitter of TR4 is also connected into the negative terminal. So next, C3, which is capacitor 2.2 microfarad 16 volts electrolytic capacitor, is connected parallel into the R4, and then connected series into the R9, which is 10k ohms 1 port watts resistor, that connected parallel into the I3. So after that, D2, which is connected parallel to the R9 and C3. D2 is also 1N4148 diode that connected into the base of TR4, connected into parallel, and then connected parallel into the C6 C6 is capacitor 273 microfarad 50 volts Mylar capacitor, which is connected into the negative terminal. So we've done on this part, so we need to erase this. So next procedure is in this R10. R10 is 1k ohms 1/4 watts resistor that connected into the positive terminal and then connected in series to the LED. LED is the small light emitting diode that connected also in series to the R8. R8 is 10 kilo ohms 1/4 watts resistor and then connected parallel to the D1. So we need to erase this part because we've done in this. And the next, we connect the relay coil into the positive terminal, and then the other one terminal is connected to the die 3, which is parallel also in TR4. And then the normally close of the relay coil is connected to the line 1 of the input of power supply, which is 220 volts AC. And then the common of the relay coil is connected to the line 2 of power supply. But yeah, And lastly, these two wires we need to connect to the load. Then we're done.
Hi there! Thank you for watching. I hope you enjoy our video.